Hey guys, so this is the last review before finals. It's Monday morning. I'll be uploading this by noon. We will be reviewing on Tuesday, but those of you who want to do really well in the final should watch this video. So on question 1 on your final, you're going to get angles that are corresponding angles, meaning that they are in the same location. So you have 4 angles in this area. You have 4 angles in this area. Both of these are in the same location. So that means they're congruent. So corresponding angles are congruent. So what you do is you take each angle and you set them equal to one another. And then all you have to do is solve for x. So you can solve for x by subtracting 139 to both sides of the equation. And that's how you get negative 9. Question 2 on the final is going to give you alternate interior angles. So they're interior angles and they're on the opposite side of the line. Alternate interior angles are also congruent. So you're going to take both angles and set them equal to one another and solve for x. So here you can solve for x by subtracting 4x to both sides of your equation by using subtraction property of equality. So you get 1x plus 5 is equal to 15. Subtract 5 to both sides of your equation, and you end up getting 10. So x has to be 10 so that both angles can be congruent. And you can check this by substituting. If you substitute 10 in for both of the x's, you should be getting 55. Question 3, these are vertical angles, and we know that vertical angles are also congruent. So x plus 125 will equal 120 degrees. We can solve for x by using subtraction property of equality, and when we use subtraction property of equality, we get negative 5. Question 4, this is a linear pair set of angles. Linear pairs are supplementary, which means that these two angles together, because they form a straight line, will have a sum of 180 degrees. So that's why you add them up and solve for x. So we're going to combine like terms. 5 and 65 don't have a variable, so those are the only like terms we have. And now I'm going to subtract 70 to both sides of my equation, which gives us 110. And when you divide 110 by 22, you end up getting 5. Question 5 on your final is going to give you a pair of same side interior angles. So these two, because it's same side, are supplementary. So this is where you add them up to 180 degrees. So x plus 90 is the first angle, then 94 plus x is the second angle. They have a sum of 180 degrees because they're supplementary. Same side interior, supplementary. Combine like terms. So x plus x will give me 2x, and 90 plus 94 will give me 184. Now I'm going to subtract 184 to both sides of my equation. So 180 minus 184 is negative 4. And when you divide both sides by 2, by using division property of equality, you will get negative 2. So in order for them to add up to 180, x has to equal negative 2. Question 6 on the final is going to give you a parallelogram. And what we know about parallelograms is that opposite angles are congruent. So that means that x plus 108 is equal to 108. So if we subtract by 108, so we can isolate our x, we're going to get 0. So the only way the two angles will equal one another is if x is equal to 0. On question 7, you're still going to work with a parallelogram, but this time we are talking about opposite sides. And we know that opposite sides of a parallelogram are also congruent. So you set each side equal to one another. Solve for x by subtracting x to both sides of your equation, and you're left with 2x minus 12 is equal to 2x minus 2 is equal to 12. Then you're going to add 2 to both sides of your equation, which will give you 14. And when you divide by 2 to isolate the variable, you will get 7. Okay, question 8. Hopefully you guys remember this is a triangle, and the interior angles have a sum of 180 degrees. So hopefully you guys remember this one. I'm going to combine like terms, which are 50, 80, and 58, and that gives me 188 plus x is equal to 180. And I want to solve for x by subtracting 188 to both sides of my equation. And when I do that, I get negative 8. Question 9 on your final. This one's a tricky one, but these are called remote interior angles. And remote interior angles have a sum of the exterior angle, which would be 6x plus 4. So 6x plus 4, the one on the outside, he's on the outside of the triangle, is equal to the sum of the two remote. So these two here are called remote interior angles. So 6x plus 6x plus 4 will equal 20 plus 3x plus 17. So I'm going to combine like terms on the right-hand side, which are 20 and 17. And I'm going to get 37 plus 3x, because 20 plus 17 is 37. I'm going to bring down 6x plus 4. And then I want to solve for x, so I'm going to subtract 3x to both sides of my equation. So I'm going to get 3x plus 4 is equal to 37. Then I'm going to subtract 4 to both sides of my equation. So I'll get 33. Use division property of equality to isolate the variable, and I end up getting 11. Question 10 on your finals, and I have a question like this. And here, because this isn't a parallelogram, we notice that opposite angles are not congruent. But we do know that a four-sided shape, interior angles have a sum of 360 degrees. So I'm going to take angle R, angle S, angle T, and angle Q, and find their sum. So I'm going to add them all up and set them equal to 360 degrees. So I'm going to start with angle T. Angle T is 10x plus 12 plus angle Q, I'm going to go clockwise starting at T, plus angle R plus angle S. And together these four angles add up to 360. So I'm going to combine like terms, 12, 98, 80, and 100. That'll be 290, I believe. It's equal to 360. I'm going to subtract 290 degrees to both sides of my equation, and that's going to leave me with 70. And then when I divide both sides of my equation by 10, I end up getting 7. So my answer is D. Number 11, they gave you an isosceles triangle. How do I know that? Because of these tick marks, which means that the base angles of the triangle are also congruent. So this question gives us the measurement of angle 2, but I know that these angles have to be congruent. So I'm going to look for those angles first, and then I'll deal with angle 2. Well, we know that the triangle adds up to 180 degrees. And if these two angles are both the same measurement, I'm going to just label them x because I don't know what they are. That means that the sum of the three angles, x plus 92, have to equal 180. These two have to end up equaling the same value. So I'm going to combine like terms. So some of you guys might be asking, how did I get x? Well, I don't know their measure, so I have to make it equal x. So x plus x is 2x plus 92 equals the sum of the all three interior angles of the triangle. Subtract 92, and I end up getting 88, right? Let's see. Can't do basic math sometimes. Babe, what's 180 minus 92? 88, right? Yeah, 88. Divide both sides by 2, and you get 44. Well, that's not the measurement of angle 2. That's the measurement of these two base angles. So I'm going to write 44 inside here. So this is 44 degrees, so is this one. But now angle 2 and angle 44 make a linear pair angle. And I know that they add up to 180. So I'm going to take the measurement of angle 2, which is x plus 142, and I'm going to add them up with 44. And again, this is a linear pair angle because it makes a straight line, 180. Subtract 44 to both sides of the equation. Oops. I'm going to combine my terms first so I don't do as much work. So I get 186. And now I'm going to subtract 186 to both sides of my equation. And when I do that, I end up getting negative 6. Number 12. Still has two angles that are congruent. So that means that their corresponding sides, which are these sides, will also be congruent. So 14 plus x equals 6. Solve for x by subtracting 14 to both sides of your equation, and you get negative 8. So again, this is an isosceles because of the two angles that are congruent. So if you have two angles that are congruent, the two sides are congruent. Number 13. If you have one triangle that has an angle that measures 60 degrees and it has tick marks on each side, that means that all of these measure 60 degrees. 180 degrees divided by 3 congruent angles. So that means angle 2, which is 4x plus 12, will equal 60 degrees. That's where I got 60 from. 60, 60, 60 is equal to 180. All sides are congruent, which means all angles are congruent. Solve for x by subtracting 12 to both sides. So you get 4x equals 48. And when you divide by 4, x ends up equaling 12. Number 14. State if the two triangles are congruent. Are they? We have to determine this. Well, I know that these two triangles are in fact congruent. And there's one piece of information that I can add to this that I should know, and that's vertical angles. Whenever you have vertical angles, you can draw these in if they're not drawn in for you. But I don't know anything else about any of the other angles. I can't make any assumptions, but I can for the vertical angles. So now I have side, this represents side, angle, side for this triangle, and I have the same thing here. So by side, angle, side, these two triangles are congruent. Number 15. This has vertical angles again, so I'm going to add this information in. But this time I give him 3 arcs because I already have an angle that has 1 arc and 2 arcs. So he needs to get 3. So I have it. I don't know anything about the sides. I only know information about the angle. So I have angle, angle, angle. Is there such thing as angle, angle, angle? The answer to that is no. It's not even an option here because it's not a triangle congruency theorem. So these two triangles are not congruent. Okay, this is the end of video 1. I'm going to start on 16 for video 2. Okay, this is now video 2. I stopped at question 15 on video 1. So I'm going to go straight to question 16. Question 16, they're asking you to state what additional information is required. Well, if there's any information I can add already based on the information given, then I can. And I can add information, and that's side LM from the left triangle is congruent to side ML from the left and right triangles have a congruent side, so I can add in the tick mark. So right now I have angle, side for both, angle, side. But I need angle, side, angle. So all the information that has sides is out. I don't need anything with sides. I need angles. Now I'm going to look at each one. I'm going to start with B because B is shorter. B is saying that if angle NLM is this one here, if he's congruent to angle QML, which is this one here. Remember, the middle one is the angle. So we're talking about L and M, but for each triangle. So if I go to the left triangle, this is angle, side, angle. That's good. And this one's angle, side, angle. So that's enough information to prove that these two triangles are congruent by ASA. This one doesn't work, and I'll tell you why. If we use NLM, that's this one, is equal to QML, that'll make it angle, side, angle. But let me check LMN. This one might be the right answer. LMN is this one. They already gave us that one. Is congruent to MLQ. That's this one. Well, that's already given, so that's not additional information, so it can't be C. It has to be B. It's just NLM with QML. So that's given already, so it can't be it. 17, I don't know why this one's on the final, but HL, hopefully you guys remember what the H stands for. The H stands for hypotenuse, and the L, leg. So here you start the same way. The only information that I know before I try to state anything that I need is that they share this leg. So the other thing I know is that if this angle is a right, so is this one, because linear pair angles are supplementary. So I know that angle UST is congruent to angle KST, which are the right angles here. I can't name them angle S because angle S is being split. So hypotenuse X just means that the hypotenuse values, which is TU, has to be congruent to the hypotenuse value of the other triangle, which is TK. So I already know the answer is going to be A. You don't need anything else about angles, so everybody that has an angle is out. And the hypotenuse and one of the legs have to be congruent. They already share legs. I already know this leg's congruent to both triangles because it's being shared. So the only thing else I need is the hypotenuse. You can't have anything else. So the OR doesn't work here. The answer is just going to be A, hypotenuse leg. There's one just like this. It's number 17 on your test. Number 18, I need to state what additional information is required. Well, I already know that because they share this side ML, I can add the tick mark because it's by a reflexive property that they're congruent. So I have an angle and I have a side. I need another angle, and I'm going to circle the angle in front of angle side because I already have angle side. So if I get angle U, he's corresponding to angle K. If I get them, this will be angle side for triangle AML, and this would be angle side for triangle KML. So I can use angle U and K, which is A, but I'm going to try the other ones. I know B is out because I don't need another side. So I'm thinking the answer is A, but I'm still going to test the other ones. So I'm going to go to C. LMK is this one, and MLU is this one. If I use them, it'll be angle, side, angle. That's not what I want. So C is out. So now I'm going to test the last one to make sure it doesn't work. Angle KLM, oh, that's already given. If it's given, you're not stating additional information, so it has to be A. Number 19, this one's one of my favorites, side, side, side. We know that CE is congruent to itself because of reflexive property for both triangles since they're sharing CE. So the only thing else I need is another side. Well, there's only one other side in each triangle. So I know that DE has to be congruent to side, ooh, I didn't name this side. Let's name him B. Sorry, I cut it off. So DE has to be congruent to BC, which means this side here will have to be congruent to this side So then you have side, side, side. Number 20, we're still stating what additional information is needed. So again, they're sharing a side, so draw in your tick marks. This time I draw in 2 because these sides already have 1. So I have side and a side. So I need the angle that's in the middle between both sides. So between this side here and this side, the angle that I need is this one, but I can't name him Q because Q is being split up. So I can name him either BQP or go backwards PQB. So BQB is right here. It can't be sides. I don't care about the sides. So for sure, it's going to be B. The other angle that's the same as BQP would be R. B is the same as R. So it would be R. Q is the same as Q. And P is the same as P. So that's 1. But let me check answer A just in case. So I'm going to erase everything here. Draw in the tick marks. That's the only thing I can add here. Angle R is here, and angle B is here. So if I have them, and I start, let's say I start here at this side, it'd be side A, which is not even a triangle congruence theorem. It's the bad one, ASS. We don't use that one. So A is out. It has to be B. 21, two sides of a triangle that have the following measures. Find the range. So if you remember, to find the range, you're going to have this inequality. The number in front is the difference of the two values given. So if you subtract 12 and 6, you get 6. And the number behind the inequality is the sum of the two numbers given, which is 18. So I know my answer has to be C. Number 22, you have to write a rule for the transformation. So we're going to check the coordinates and see if anything happened here. If you look at just I focus on I, the values from I to I prime didn't change signs. They totally changed. So this is probably telling me it's a translation. So I'm going to try to figure out what they did to the X and Y values and then apply it to at least one more point and see if it's right. To go from 1 to -2, negatives are confusing, so I'm going to go with G, point G. Let's look at point G instead. G to 2, 5 to 2. What did they do to 5 to get to 2? They subtracted by 3. 5 minus 3 will give you the 2. So let's check if that's in fact what happened to the X, okay? So let's try all the X's now. Oops. So I'm going to go to I real quick. Is 1 minus 3 -2? The answer is yes. Is 1 minus 3 -2? The answer is yes. So I know that this is a transformation. 3 units left because this is for your X value. Now I'm going to check the Y coordinates. And again, I'm going to go with G. So to get from -4 to 3, what do they add to -4? Well, they have to add 7. So let's check if they added 7 to -2 here to get to 5. Is -2 plus 7 5? Yeah. Is -4 plus 7 3? Yeah. So that means that there's a translation of 7 units up because this is for your Y. If you get confused, you can also graph them. I'm going to graph G. 1, 2, 3, 4, 5. 1, 2, 3, 4. Here's G. G prime is 2, 3. So you can check how many units they moved to the left. So to the left they moved 3 units. And then how many units did they move up? They moved up 7. So it's still 3 units left, 7 units up. So if you need to use graph paper for 22, you can. 23, we have to write a rule to describe the transformation. So this one's a little tricky. Be very careful on the final because if you notice, this one starts with G, but then G does not correspond to G prime. So we have to be really careful. So G, oops, let's see, G should go to G prime. right? So I'm going to focus on g and g prime. What happened to the x value? Nothing, straight 0. So that doesn't really help me. What happened to the y value? It stayed the same. So right now I know that y value is the same. If all the y values are the same, then that means it's probably a reflection. Let's check h. 2 to negative 2. So the x value changed from positive to negative. Okay? How about the y values? Did the y values change? No, they stayed the same. If the y values don't change and the x values only change from positive to negative, then this is a reflection across the y-axis because your y value did not change. That means that your reflection went across the y. So the coordinates for the x change, but the y value stays the same. So if I verify that the y value for point I and I prime are the same, then this is a reflection across the y-axis. 24. There's only 3 transformations, so that means this one has to be a rotation because there's only giving you one of each. One translation, one reflection, one rotation. So I'm guessing this is a rotation, so I'm just going to look at the pattern. C to C prime, the x values change signs. Same thing with the y. Same thing with the x value for point D. Same thing with the y value. So all that's happening here is that they change signs. So if they're just changing signs, this is a rotation of 180 degrees. 25. The polygons in each pair are similar. That means that the sides are proportional. Find the missing side. Well, 12 corresponds to question mark. I'm going to write x equals. I don't know this value, so I can't use 15. They're corresponding. I don't have enough information. But 16 does correspond to 24. So if you cross multiply and solve for x, you can solve this. Or I can reduce 16 24s by 8, getting 2/3, which will make my fraction way smaller. These are equivalent, so I can do this. Cross multiply, I get 2x equals 36. And when I divide by 2, x is equal to 18. So this has to be 18 for them to be similar. This is the end of video 2. So I'll start the next video at question 26.